Alright, so I'm going to go through and highlight the important information or underline it. You're drinking a large Mountain Dew, which contains 147 milligrams of caffeine to start with. The half-life of caffeine is 6 hours. And you begin eating at 10 p.m., 10 o'clock. What time will it be when your body has eliminated all but 80 milligrams? So what time is what we're looking for, and we're still going to have this much left. So the half-life formula is y equals a 1/2 to the time elapsed over the length of the half-life. Right, so remember, in that exponent, you're basically trying to figure out how many half-lives have happened. So if the half-life is 2 hours and 4 hours have passed, then you would do 4 divided by 2, indicating that 2 half-lives could have happened, because you would have one every 2 hours. So if 4 hours have passed, then you've had 2. So that's when we look at it with simple numbers, we can understand what to do, maybe with less intuitive numbers, right? So the initial amount is this 147. That's going to be A. And then we want to know what this time is. That's what we're looking for. What time will it be? So how much time has passed? The half-life right here is going to be the 6 hours. And then this 80 milligrams is how much is left. So that's going to be the y. This is the initial amount. So this amount is how much is left. So we'll plug these numbers in. I'm just going to use t for time elapsed, and I'm going to use 6 for the half-life. So I need to make a note here that my t is going to be in hours, because that's what the 6 is in, and I need to make sure that I'm using the same numbers there. Alright, so grab your calculator. Let me get a good one that you can see. And to solve this, the first thing we want to do is we want to divide by 147. So we're going to do 80 divided by 147. So you get 0.544 equals 1/2 to the t over 6. So now to solve this exponential, we're going to use logarithms. And so if you do the log of, you can do the log base 1/2 of this number equals t over 6. So we're going to say the log base 1/2 of 0.544 equals t over 6. So there are two ways that you can now solve this. If you have one of the newer calculators, you can actually put this straight in your calculator. If you don't have it, then you can just use the change of base formula, which says you can take the log base 10 of this number and the log base 10 of this number and then just divide them. So the change of base formula says you can do log base 10, or you don't have to write it, it's the common log, 0.544 over the log of 1/2, also base 10, equals t over 6. So, let me see. Let me get a newer calculator and I'll show you what it does, if I have one. I don't happen to have one. That's fine. So you can do this, you can just calculate it this way. So we're going to type in log of 0.544. And remember, you don't need a base. If there's not a base there, we assume it's a log base 10. That's the common log. And we're going to divide that by the log of 1/2. And then you can see all you need to do to finish solving this is now to multiply by 6. So I'm going to go ahead and do that in my calculator. So t equals 5.2, we'll call it 27, and remember that was in hours. It's going to take that many hours to get to this amount of caffeine left. But the question doesn't say how many hours pass, it says at what time. So if you started at 10 p.m., well, this is obviously going to be 5 hours after 10 p.m., but also that 0.27. So 0.27 of an hour, to convert that into minutes, you would multiply it by 60 because there are 60 minutes in an hour. So we're going to take just that portion. We know that that's 5 hours. We're just going to take this portion and figure out how many minutes it is. It's evidently 16.2 minutes. So it's going to be 5 hours and 16 minutes. We can, the 0.2, we'll just round that off and call it 16 minutes. So at what time is 5 hours and 16 minutes after 10 p.m.? Well, 10 to 11 is 1 hour, 11 to 12, 12 to 1 a.m., 1 to 2, 2 to 3. So it's going to be approximately 3:16 a.m. by the time that you still only have 80 milligrams of caffeine in your body.